Hi everyone, welcome to section 2.6. We are going to be doing the continuation. We are going to be solving rational inequalities. And for this one, we are going to also focus on what's going on at the denominator. So remember, first, we always want to be able to have one side equal to zero or to be zero, which in this case it already is. Now, the thing is, we have to set both the numerator and denominator to zero. So the numerator, to find the boundary points. So you're going to set the numerator equal to zero to find the boundary points. And you're going to look at the sign of the inequality. So the numerator is x minus 1, x plus 3 is less than or equal to 0. However, if we have x minus 1 equals 0, x plus 3 equals 0, since it's already in its factored form, I'm going to find x equal 1 and x equal negative 3 to be my first boundary points. Now, these boundary points will be closed interval. Why closed? Because it contains an equality. It's a less than or equal. Because it contains an equal, then I'm going to have a closed point, or they're going to be included. So those boundary points will be included. Now on the denominator, when the denominator is equal to 0, it will never be included. So x minus 4, set it equal to 0, which is now the denominator equal to 0. That makes x equal 4. 4 is also a boundary point. However, the distinction between the first boundary point and the denominator's boundary point is that the boundary point of the denominator is never included. So that boundary point, we are going to have negative 3, which is going to be included, or bracket. I'm going to have a positive 1. It's also included because it's 1, negative 3, and positive 4. 4 will not be included. So now that I know my boundary points, I'm going to be having some test points, a value that I'm going to test in between negative infinity and negative 3. Let's say negative 4. I'm going to plug in 0. I'm going to plug in 3, and then I'm going to plug in 5. So now how many test points do I need? 1, 2, 3, 4 different test points. So if I'm going to test negative 4, I have to look at the sign, and I'm going to substitute it. And then again, I'm going to be substituting that value into the original. So I'm going to now be doing the substitutions over here. Substitute the test points. So I'm going to have 4 different test points. So the first test point is going to be negative 4. Negative 4 minus 1, negative 4 plus 3, negative 4 minus 4. Is that less than or equal to 0? Let's check. Well, negative, it's going to be negative 5, it's going to be negative 1, and then negative 8. Is that less than or equal to 0? Well, 5 and a negative, it's going to be a negative. So this value, it's negative. Is that less than 0? Yes. So I'm going to shade this region, which is true. Now let's plug in 0. I'm going to test 0. 0 minus 1, 0 plus 3. 0 minus 4. Is that less than or equal to 0? Well, let's say I have a negative 1, I have a positive 3, and then a negative 4. That gives me something positive, right? So 3/4. Is 3/4 less than 0? No, so I will not shade that area. Let's see, let's plug in 3. So I have 3 minus 1, 3 plus 3 over 3 minus 4. Is that less than or equal to 0? Well, I am going to have a positive 2, a 6 over a negative 1. That's going to be negative 12. Is that less than or equal to 0? Yes. So I will also shade this region. And last but not least, let's try 5. If I try 5, it's going to be 5 minus 1, 5 plus 3 over 5 minus 4. Is that less than or equal to 0? No, they're all positive. So positive 4 times an 8, divided by a positive 1, that gives me something positive. So my solution is actually the shaded areas right here. And that answer, so my solution is going to be an interval from negative infinity to negative 3, including the boundary, union 1 to 4, where 4 is not included. See how 4 is not included here? So 4 is not included, but 1 and negative 3 are. So every time you have a rational inequality, you first set one side equal to 0, and then you want to factor, and then you want to make sure that you find your boundary points, but you restrict the denominator boundary point. So let's look at question 7. In question 7, the first thing you look at is that there's a 3. So it looks like x minus 5 over x minus 7 less than 3. I have to bring the 3 over by subtracting the 3. X minus 5 over x minus 7 minus 3 over 1 is less than 0. In order for me to combine the denominators must be the same. So I'm going to multiply top and bottom by x minus 7 only to the 3. So I'm going to rewrite it as x minus 5 over x minus 7 minus, I got the negative, negative 3x plus 21 all over x minus 7 is less than 0. So then the denominator is only a single denominator. So I'm going to have x minus 5 minus 3x plus 21 all over x minus 7 to be less than 0. Now I'm going to combine like terms, and I'm going to have a negative 2x. I'm also going to have a positive 16 is less than 0 over x minus 7. Now I'm going to factor out, I can factor out the 2 and solve for the numerator, or set the numerator equal to 0. That's going to be negative 2x plus 16, set that equal to 0. And look at the inequality. This is a strict inequality. That means that it's strictly less than 0, so it will not include the boundary points. So what would be that boundary? Well, that boundary point, it's negative 2x is equal to negative 16, x is equal to 8. So x equal to 8 is not included. And that's because of the inequality, not because it's in the denominator. Okay, so pay attention. Now, if I set the denominator, x minus 7 is equal to 0, right? So set the denominator equal to 0. That's also not included because we have a restriction. It's at x equals 7. So that's your boundary point as well. So both of these are not included. So then I'm going to have 7 and 8. And then they're both not included. And I'm going to have to find some test points. So a test of value less than 7, I'm going to put 0 in between. So 7.5. And then after, let's put 9. So I'm going to place those values in the original value, the original formula. So it's going to be negative 2 times 0 plus 16 over 0 minus 7. Is that less than 0? Well, this is 16 over negative 7. Is that less than 0? Yes. So I'm going to shade this region. Let's find something in the middle. Well, something in the middle would be negative 2 times 7.5 plus 16 over 7.5 minus 7. Well, what is 7.5 times 2? Well, 7 times 2, right? So 7.5 times 2, that's 15. So I have 15 plus 16 over 0.5. This is going to be negative 15 plus 16, that's 1 over 0.5, that's going to be 2. Is that less than 0? No, so I don't shade this region. And let's try 9. So negative 2 times 9 plus 16 over 9 minus 7. That's negative 18 plus 16 over 2. Is that less than 0? Yes, because negative, it's going to be negative 2 over 2, which is less than 0. This is negative 1 less than 0. Yes. So I will also shade this region. So my solution over here, right, is the shaded region from negative infinity to 7 and from 8 to infinity. As a solution, it's negative infinity up to positive 7, not including 7, union, parentheses, 8 to infinity. And that would be the solution for this question. So we're going to do the same thing for question number 8, and then we'll finish question 9. And then we have one more, and that's going to be the end of section 2.6. Alrighty, so let's do question 8. So for question 8, we want to move one side or the other. It doesn't really matter which one. So it's 1 over x plus 6 minus 3 over x minus 2 to be, in this case, greater than or equal to 0. So then what did this say? What is this saying? Okay, well, common denominators. So the denominator here would say the LCD would be x plus 6, x minus 2. So I'm going to multiply the top by x minus 2, and then x minus 2 times x plus 6 minus 3 times x plus 6 over x minus 2, x plus 6. And that's going to be greater than or equal to 0. Now I'm going to clean up the numerator, x minus 2 minus 3x minus 18 all over the LCD, which is x minus 2, x plus 6, to be greater than or equal to 0. Now let's play some cleanup here. When we do some cleanup, I'll have negative 2x minus 20 over x minus 2, x plus 6, greater than or equal to 0. So then I'm going to factor out the negative from the top, and it's going to be 2x plus 20 over x minus 2, x plus 6. And then I'm going to multiply both sides of the equation because I factored out the negative. Multiply both sides by negative 1. When I multiply both sides by a negative 1, the inequality flips. So let's put a star here. So when you multiply or divide a negative value to the inequality, the inequality will flip. So now, because I multiplied it by a negative 1, I'll have 2x plus 20 over x minus 2, x plus 6 to be less than or equal to 0. Now I'm going to set the denominator equal to 0 and so if I set the denominator equal to 0, I'm going to have my boundary points to be not included. So x minus 2 equals 0, that's x equal to my boundary point not including because it's denominator, and then I have x plus 6 to be equal to 0. That gives me x equal negative 6 as my other boundary point where it's also not including. And the last one I have to do is when I have my set the numerator equal to 0, if the numerator now is equal to 0, it's 2x plus 20 equals 0. That gives me x is equal to negative 10. And negative 10 will be included. Why would that one be included? Well, you are including it because you have a less than or equal to, because you have equality your numerator will be included on the solution. So I'm going to do my intervals here. I'm going to have -10. I'm going to have the value 2, or sorry, -10, -6, and +2, where only the one that's included will be the -10. -6 and 2 are not included because those are in my denominator. So take a few moments and go ahead and plug those in. Tell me what you guys get. So I'm going to plug in a test point of -12, a test point of -8, a 0.0, and then a 0.3. And I'm going to look at the signs when I test them. Go ahead and find your solution. I'll give you a few seconds. So this is the timer. You pause the recording and you check. Alrighty.